Hello. So again, we're going to have an optional exercise at the end of the lecture in case you're just desperate for more economics content. I want to note that this extra example is going to be a little bit unusual because I'm going to walk you through a problem starting with the absolute bare essentials, right? We're going to work our way from a firm production function all the way to a long run market equilibrium. And because this is going to be a really long problem, I'm going to break this up into two videos. So the first video is going to try to get us to the point of solving an equilibrium problem where we have a market supply curve, a market demand curve, a labor demand curve, and a labor supply curve, right? Trying to figure out how to find our equilibrium in those two markets. The first video is going to get us to that point. So it's going to help us figure out how to find our labor demand, how to find our market supply given our production function here. So if you want the full kahuna, right, you want to experience the beauty and depth and grace of market equilibrium in the maximum possible extent, watch this video and watch the video following that. If you would rather cut to the chase and get to a more limited version of the problem, right, where we're just doing the new stuff, then skip this video, watch the next one. And if you don't want to do any of this, turn off YouTube and go throw a frisbee around or do whatever it is you want to do. Okay, great. So we've got a problem here where we have some industry, right? Let's say that we've got like the market for tarot card readers, right? We have a production function here that's a function of labor, right? Specialized people who have the gift of second sight, capital, right? The tarot cards themselves, the pillows and cushions and all this sort of stuff, right? Creepy decorations. Clearly I don't know what I'm talking about here, right? And we know the following, right? We have a competitive market for capital where the rental rate of capital is just 1, right? We have a perfectly elastic supply of capital, but we have a limited number of people capable of reading tarot cards, right? We're going to have perfectly inelastic supply of labor where no matter what the wage is, 100 people are willing to do this work. Then in addition, right, we know that the demand for tarot card readings is given by this, right? 25,600,000 divided by p squared. And our goal in all of this is to figure out basically what our long-run equilibrium is going to be, right? We want to use this information to find a price, a total quantity of tarot card readings, wage rate for tarot card readers, and a number of readers employed. Okay, so where do we want to start? As usual, I like to start by drawing a picture, right? Let's see what we know. Let's figure out what we need to know. So what we know is the following. I've got two markets. I'll say market for Q and a labor market. Sorry, give myself more space, right? So I'm going to have Q and I'm going to have P. Then I've got a labor market. Where I'm going to have number of workers, L, and I'm going to have a wage rate, W. Right? Lovely. Now, we can put a couple things on here right now, which I'm going to do in black. These are the things we know. So we know that labor supply is just fixed at 100. Right? We know that quantity demanded is a curvy thing at 25 million divided by p squared. Right? Squared, labor supply equals 100. Great. What we don't know, right, what we need to know are the other two chunks of this market, right? We need to know our quantity supplied as a function of P, and we need to know our labor demanded as a function of W. Right, and for now, I'm putting these as blue dotted lines, and I'm being very vague because we're not really sure what we're going to get yet. So what we're going to try to do, right, our first task here is going to be to take the information we have here to figure out these two objects, right, our quantity supplied and our labor demanded. So let's think about quantity supplied first, because I think this is closest to what we've experienced before. How will we find our market supply curve? Well, what we would need, right, is we could figure out an individual firm's supply curve, right, figure out a firm's cost functions, etc. Then we could work our way from that to thinking about our long-run market supply, right? So our basic idea here is we want market supply, right? So first we're going to get our quantity supplied for the firm, right? In order to get our quantity supplied for the firm, we would need our marginal cost and our average total cost. So we would need our cost function, C of Q. This makes sense? And I'm saying C of QW here because we don't know the wage yet. So this is going to be our first objective, is to find our cost function in terms of Q and in terms of W. So how are we going to go about trying to find our cost function? Well, we know that C of QW is just going to equal W times L of Q plus R times K of Q, right? As always. So what we really need is L of Q and K of Q. How do we go about finding L of Q and K of Q? Well, what we're going to need to do to find L of Q and K of Q, right, is we're going to want to say for any particular Q that we want to produce, we're going to want to find our cheapest one, our cheapest combination of labor and capital, right? This is going to be our first objective. So the first thing we're going to do is we're going to find L of Q, K of Q, and thus C of Q by finding our MRTS, right? Plugging it into our isoquant, solving our cost minimization problem. So A, we're going to want our MRTS in terms of L and K, which should equal dF dL over dF dK. Wonderful. Okay. So what's dF dL? Well, dF dL is going to be the derivative of this thing with respect to L, right? So this is going to be 1/4 times 16L to the minus 3/4 K to the 1/4, right? Derivative of 4, the 4 doesn't matter because it's added here, right? Derivative of 4 with respect to L is just 0. Derivative with respect to K, 1/4 16L to the 1/4 K to the negative 3/4. So this whole thing simplifies, right? The 1/4 cancel, the 16s cancel. I end up with K to the 1/4 divided by K to the negative 3/4, which is K. L to the negative 3/4 divided by L to the 1/4, which is 1 over L. So I end up with an MRTS of K over L. Beautiful, we're off to a great start. What do I do from here? Well, I can rule out corner solutions, right? Because if I didn't have any L and I didn't have any K, I wouldn't have any output. So I'm going to be able to go straight to MRTS. So I'm going to say no corners. So MRTS of L and K has to equal our wage rate over our rental rate, right? The amount of capital it takes to replace a worker has to equal the amount of capital I could buy with the wages I pay a worker. So that means K over L equals W over R. This tells me that K equals W, oh, and sorry, R is 1, right? So this is just going to be W times 1. I'll put it down here. W times L, right? Because R equals 1. Wonderful. And what do we do from here? So now we know, right, that in order for our isoquant and our isocost to have the same slope, we need to have K equal W times L. The other thing we need to solve our cost minimization problem is we need to be producing enough output. So the next thing we need is we need that Q equals F of L and K, right? So Q has to equal 16L to the 1/4 K to the 1/4 minus 4, right? This is how much we get from a particular amount of L and K. Then we can plug in our value for K right here, right? So we'll say Q equals 16 times L to the 1/4 times WL to the 1/4 minus 4. We can combine those L's, so we'll say Q equals 16 W to the 1/4 L to the 1/2 minus 4. And now we just have to solve for L, right? So we'll say L to the 1/2 equals Q plus 4 over 16W to the 1/4. L is going to equal Q plus 4 squared over 16 squared W to the 1/2. Does this make sense? 16 squared is 256. So we'll get from here, L equals Q plus 4 squared, I'm actually just gonna leave it at 16 squared for now. Over 16, I'll do it. We can all have fun with our powers of 2. 256 w to the 1/2. K, of course, is just going to equal WL. So that's going to be Q plus 4 squared over 256, right, times W over W to the 1/2, so times W to the 1/2. Okay, great. So now that we know L and K, we can find our C as just WL plus RK. Right? So this is going to give me Q plus 4 squared over 256 W to the 1/2 times W plus Q plus 4 squared over 256 times W to the 1/2. Right? So of course this is going to be just times W to the 1/2. So we'll end up with a C of Q and W given by Q plus 4 squared times 2, right? So over 128 times W to the 1/2. Make sense? Okay. So this is our first intermediate objective, right? What we've been able to figure out so far is given our production function, we've gotten to a cost function, right, in terms of W. We know how much it would cost to produce Q units of output using W units of labor. I'm sorry, with a wage rate of W, right, when we're producing the cheapest possible way. So what I'm going to do now, unfortunately I can't fit this whole problem on one board, so what I'm going to do now is I'm going to take what we just produced, move it over here, and keep chugging. So what we have so far is C of Q and W equals Q plus 4 squared over 128 times W to the 1/2. Lovely, right? This is what we've just figured out. And now I'm going to erase all of this, all of our precious work, so that we can make space for the next bit of even more precious work. Okay. Okay, so the reason we found a cost function, right, the reason we did all of this was because we were hoping that finding a cost function would help us figure out a firm supply, right? Our next goal is to find the firm's quantity supply, right? The reason we want the firm's quantity supplied is because that should help us find the industry quantity supplied. In order to do this, right, I'm going to need my marginal cost, I'm going to need my average total cost, right? So our next step is going to be using our cost function to find our marginal cost, find our average total cost. Why is it that we want our marginal cost and our average total cost? Because we want a picture that looks like this, right? I have a marginal cost, let's just say upward sloping all the time, marginal cost of Q like this. I have an average total cost like this, right? And I'm going to have a firm supply curve that's just everything above my average total cost along my marginal cost, right? Just like this. This is why we want our marginal cost and our average total cost, right? And right here, we're going to have, where we first start supplying, a special Q star, special P star, where the firm isn't making any money at all, right? And they're just beginning to supply output. Great. This is our goal, right? So we need this. So what we're going to need is first to find the marginal cost in terms of Q, which of course is going to be the derivative of C with respect to Q. Yeah? Yeah. So we want the derivative with respect to Q of Q plus 4 squared over 128. Now, I've done this before by splitting this up, right? Turning this into a Q squared plus 8Q plus 16. This time I'm going to do this, leaving it as Q plus 4 squared and using the chain rule. And the reason I'm going to do that is just so that you're comfortable and familiar with both of these methods, so that in the future, right, let's say that this was to the 3/2 or something that doesn't split up nicely, we are still able to continue on with our lives, right? We don't just faint in despair and move on. Okay, great. So what are we going to do here if we chain rule this thing? Well, we'll say that it's going to be the derivative of the inside, right, times the derivative of the outside. So this is going to be derivative of something squared, it's 2 times that something. Derivative of q plus 4 with respect to q is just 1. So we'll get q times q plus 2 plus q times 4 times 1 over 128, right? Which if we prefer, we can just call q plus 4 over 64. Wonderful. Second thing we need, right, is our average total cost. Which is just going to be C of q divided by q, right? So this is going to be q plus 4 squared over 128 q. And I'll again just leave it just like this. So what do we do from here? Well, what we're going to want to care about, right, our ultimate goal is to find our long-run market supply, right, at a particular wage. What's our long-run market supply going to be? Well, it's going to be the amount of labor, or it's going to be the price at which firms are just breaking even, right? So we have no entry, we have no exit, right? Our long-run market price is going to be this P star right here. So what we want is we want to find P star. Long-run market price. Price starts with a P. Right, and we're going to do this by finding Q star, where marginal cost equals average total cost. Right? And then we'll be able to figure out P from Q star. So the next thing we want to do is we want to set marginal cost equal to average total cost. Right? And what's this going to let us do? Well, we're going to say that Q plus 4 over 64 has to equal Q plus 4 squared over 128Q. Great. So I'm going to divide both sides by Q plus 4. That takes care of that. I'm going to multiply both sides by 128Q. That's going to tell me 2Q equals Q plus 4. So this is going to tell me that 1Q equals 4. Amazing. Right? So what we've just figured out is that each of our firms is going to produce precisely 4 units of output. Right? Wonderful. Now that we know that, we can figure out our price by plugging this into our marginal cost or our average total cost. And I generally prefer our marginal cost. So we'll say P equals MC of Q star equals Q star plus 4 over 64. So P is going to be, right, 8 over 64. What happened to our... Oh, I'm so sorry. I forgot my W to the 1/2 in here. So this should have been W to the 1/2. This should have had a W to the 1/2. This should have had a W to the 1/2. This should have had a W to the 1/2. Then they cancel each other out, right? So order is restored to the universe, but this is very important, right? Our marginal cost has to depend on W, right? The higher the wages, the more expensive it is to do things. So sorry, so our price should be 8 Q plus 4 over 64 times W to the 1/2, right? Which is going to be 8 over 64 times W to the 1/2, which is going to be 1/8 W to the 1/2. Okay, great. So what we just figured out is that the long-run market price has to equal 1/8 W to the 1/2. Now this is really, really important. This is really nice. Because what this tells us is that our quantity supplied at any particular price and any particular wage rate W is going to be any amount as long as the price is exactly equal to 1/8 W to 1/2. Right? Because if we had a really high demand, more and more firms would enter until the price was driven down to this amount. With really low demand, firms would exit until, again, price was driven up to this amount. So we can say that our quantity supplied is going to be 0 if price is less than 1/8 W to the 1/2, 0 to infinity if price equals 1/8 W to the 1/2, and infinity if price is greater than 1/8 W to the 1/2, right? In other words, over here, we can fill in some blanks for ourselves here. We can say that our quantity supplied at P and W is equal to just what we wrote, right? And I'm being a little sloppy because we already have it over here. Great. Okay. What else are we able to do now that we know our price and now that we know our market supply? Well, the other thing that we cared about, right, our other goal was to figure out our labor demand. So what can we do about labor demand from here? Well, one thing is relatively straightforward, which is we could figure out how much labor a particular firm is going to demand. How can we do that? Well, we know that each firm is making 4 units of output. Exactly, right? Each firm is making 4 units of output. We also know, although I did erase it, we also figured out how much labor firms were going to hire for a particular amount of output. Right? I believe what we had here is that firms were going to have L equal to, what was it? Sorry that I erased this. It was Q plus 4 squared over 16W to the 1/2, right? So I know how much labor a particular firm is going to hire for a particular quantity of output. What this is going to allow me to do is to say the firm labor, each firm is going to hire 4 plus 4 squared over 16 workers, right? This is 8 squared over 16, so this is 64 over 16 is 4 workers. Again, over W to the 1/2. So sorry. 4 over W to the 1/2 workers. This makes sense? So how many workers are going to be hired in total? Well, total labor demand is going to be 4 over W to the 1/2 times the number of firms. Right? This makes sense? Each firm is hiring 4 over W to the 1/2 workers. So total number of workers is going to be 4 over W to the 1/2 times the number of firms. So how many firms are there going to be, right? This is the last thing that we need in order to be finished with the first part of this problem. Well, we know that we're going to produce a total output, which we'll call big Q, right? This is the total output supplied by the market. So Q is going to equal little q, the amount each firm is going to make, times the number of firms. Right? So the number of firms is going to be big Q over little q, which in this case is big Q over 4, right? Because we knew that each firm was going to make 4 units of output. This makes sense? So we can say that our labor demand for a particular wage and a particular level of output is going to be 4 over W to the 1/2 times big Q over 4, which of course is just going to be big Q over W to the 1/2. So over here, right, I now have a solid start here as well, right? I can see that my labor demand curve is going to depend on W and Q, and is going to be big Q over W to the 1/2. Okay, wonderful. So that concludes the first part of solving this problem. Right, now that we've done all this work, we've gotten ourselves to a point where we have supply curves, we have demand curves for each of our 2 industries. Right, in the quantity market, we know that the amount supplied is just going to be anything as long as P equals 1/8 W to the 1/2. Amount demanded is going to be what we were given, right? 25,600,000 over P squared. We know that in the labor market, we're going to have exactly 100 workers working, and we're going to have a demand for labor given by Q over W to the 1/2. So all that we have left to do is figure out how to solve for an equilibrium in both of these 2 markets, which I'm going to do in a second video. Okay, great. See you in a minute.